Professor Barak Khoshnevis is the director of the Center for Rapid Automatic Fabrication Technologies at the University of Southern California and a creator of Contour Crafting, a technology that has the potential of completely transforming the construction industry as we know it. Professor Khoshnevis, thanks for joining us.
Thank you for inviting me.
Professor, let's talk about 3D printed housing. Are we really coming to the age of designing our dream house on a computer and literally printing it and moving in?
I think we're there, almost. Everything that we use is pretty much produced automatically, with the exception of buildings. And it is really time to also automate building construction. And with the 3D printing technology, I think for the first time, this challenge is now has become a feasible prospect.
Could you explain to us better how Contour Crafting works?
It is basically a mobile system that you can easily deploy it on site. The machine collapses into three main pieces, and then you put it on a flatbed truck and you take it to the site. And in a matter of 30 minutes to an hour, you erect the machine. You bring the material and connect the material line and bring the architectural design on a flash drive, let's say. Then you press a button and the building is going to be built on site at an unprecedented speed with an unprecedented architectural flexibility. So,
based on what you're explaining to us, how long would it take to build a two-story house?
For a total of 2,000 to 3,000 square foot, you will need less than 24 hours.
Wow. Now, I know that there was a specific event that motivated you to apply this technology to housing. What was it?
Currently, according to United Nations statistics, there is a need for over 800 million houses, nearly 1 billion houses in the world. And of course, this demand is going to keep continuing over many years. And we really don't have a way to respond in an appropriate way. About 2 billion people live in slums or are homeless. And about 40 million people are uprooted every year due to war and natural disaster. There's really not a rapid approach, a cost-effective approach to respond to these needs and create dignified permanent housing for people. And it's really time for technology to respond to this. And I think the only possible way is using technology.
Along those lines, you've mentioned, disaster zones. And I know one of the reasons that you decided to start this was visiting Iran after an earthquake and seeing that, housing as it is right now could easily collapse when facing natural elements. One of the main concerns that a lot of people have is it really safe and can it really withstand the natural elements when we're thinking, well, it's a printer putting the structure where people are going to be living together?
First of all, anything that robots and machinery make typically is more reliable, more consistent than what people make. People are great, of course, but they're great for creating concepts. With the method of construction, of course, you have to have good designs and good materials. If you have the best method of construction or the best human construction crew, if you give them weak materials, and if the designer designs the walls very thinly and makes structurally poor design, of course, the building is not going to be strong, regardless of who builds it. And the case is true for Contour Crafting as well. Besides a good technology to build, you have to have good design and you have to feed the system with good material in order to assure strength.
Okay, now I understand that Contour Crafting is funded by NASA. Do you see this technology being adopted by governments around the world anytime soon? Again, referring to natural disasters, refugee housing.
I really think so. Hopefully as early as next couple of years. Or
One of the very, very interesting things about Contour Crafton is that for most people, the sky is the limit when it comes to dreams, inventions, possibilities. However, for you, the sky definitely isn't the limit because part of your vision is to use this technology to build habitats in outer space. Where else are you planning to take this technology?
space, of course, is an important and interesting prospect. We are fortunate to have the attention of NASA. We are in the third phase of our project for building infrastructure elements on Moon and Mars. I mean, preparing the technology to do that. It may or may not happen in my lifetime, but we are definitely very enthusiastic about taking the early steps towards making that vision a reality.
The main obstacle that we're running into is finances. So if let's say, if hypothetically we had all the money that's needed for the research and to, start working either in Mars or on the Moon, in about how many years would you see this as a possibility, as something that we would say, hey, there is a house on the Moon or in Mars?
Really, for Moon, it is conceivable that we could have a system that can build the basic infrastructure elements like landing pads and blast protection walls and roads and hangars and shade walls in about 7 years.
Wow. Wow. Well, considering Contour Crafton has already been identified as one of the major disruptive technologies of our time, we'll definitely be looking forward to how these projects develop. Professor Khoshnevis, thanks again for your time.
Thank you. My pleasure.